Hi, this is Reddy Mereddy. This video is about Python assignment on goldbach deuce. Let me share my screen. So as you look at this is the screen. This is the code. If we run the code, enter any number between 0 to 100. We'll enter 55, range 50, as you can see. So explain how your approach works. So first, get I and get n functions obtain users input for I and n respectively. As you can see here, this is the get I and get n, and this is the I and n. So I and n represents the size of list, and I represents the size of list, and n is the target sum to find in a list. As you can see here, get list of I function generates a sorted list of I random integers. This is the get list of I function. It uses the random.sample function, as you can see here, to create a random sample of unique integers between 0 and 100, sorts the list and returns it. As you can see here, it sorts and returns binary search of x comma nums comma low comma high. As you can see here, this is the function, is a binary search function used to find an element x in a sorted list nums within the specified low and high indices. As you can see here, the function recursively searches for I by dividing the search range in half until it either finds the element or determines that it doesn't exist. As we can see here, the division by 2 in each iteration of the binary search is the reason the code has time complexity of O log n for each search operation. And prime numbers n comma 1 function iterates through the sorted list 1, as we can see here. And for each element calculates the second number requires to reach the target sum n. It then calls binary search to search for this second number in the sublist of 1 to return the current element. If it finds a pair of sums to n, like if you see here, so if it finds a pair that sums to n, it prints the pair and breaks the loop, as we can see here. If no pair is found in entire list, it prints a message indicating that no pair exists, as we can see here. In the main function, it collects user inputs, generates the sorted list, and prints out the pair of numbers that's sum to the target value n, or an error message if no such pair exists, as we can see here. So, explain why our code runs in O of n log n. So, regarding the time complexity, the code runs in O of n star log n. The primary reason for this time complexity is binary search algorithm used to find pairs of number in the sorted list. The outer loop in the prime numbers function iterates through the list. So it has a time complexity of O of n. For each element in the list, the binary search is performed, which has a time complexity of O of log n. As a result, the overall time complexity is O of n star log of n, assuming that the binary search is the most time consuming operation in the code. Thank you.